Boleh kita mula? Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good afternoon from Malaysia, and good day to all participants who are joining us through Zoom session. Ladies and gentlemen, welcome to day 2 of Newton-Ungku Water Symposium and Webinar 2020. For today's program, there will be 2 sessions. The first session is UK-Malaysia Water Expert Forum, which will be presented by distinguished panelists from UK and Malaysia. Meanwhile, for the second session is Newton Sharing Session, which will be presented by researchers from this collaborative program. Without further ado, let's begin our first session of the day. For your information, this session will be broadcasting live on Facebook and YouTube. With all due respect, I invite the moderator of this session, Prof. Dr. Azmi Aris.
I'd like to welcome everyone to UK-Malaysia Water Expert Forum, which is part of our Newton-Ungku Water Symposium and Webinar 2020. As mentioned just now, this is a hybrid program, hybrid mode. We have physical panelists with us here and also audience in this room, and we also have panelists and audience connecting to us online. The topic that we are going to discuss today would be the linkage between wastewater, health, and sustainable sanitation. And with me today, I have 2 eminent figures, one from Malaysia and the other one from UK. From Malaysia, we have the Secretary General of Ministry of Environment and Water, Datuk Sri Dr. Ujang. Selamat datang, Datuk. And thank you very much for having us in your schedule. Despite your busy schedule, we are so fortunate to have you here. I think everybody in this room and also abroad, we know about Dato' Zaini very well, and it will be too long for me to read his biography, but I think it is sufficient enough to mention that Dato' Sri Zaini Ujang is the Malaysian national figure for his contribution as public administrator, professional environmental engineer, academician, innovator, author, and environmentalist. So with this, we are so fortunate to have him here. And across the globe, we have Professor Dr. David Graham from Newcastle University, UK. Professor Graham is a professor of ecosystem engineering. Among his research interests include transmission, fate, and impact of antibiotic-resistant genes in the environment, resulting from human activity, energy minimization in water and wastewater system, and also water and environmental quality in the developing world and the developing and emerging world. And for information too, Professor David is the lead investigator for this Newton project on the UK side. Okay, our topic today, which is the linkage between wastewater, health, and sustainable sanitation, is quite broad. And we only have a very limited time, about an hour to discuss on this. So today we would like to focus our discussion more towards decentralized sewage treatment plant. And for those who are not familiar with this topic, decentralized sewage treatment plant, decentralized treatment plant which cater relatively small population. Sometimes it can be less than 10 people, and sometimes it can be maybe around hundreds of population. Whereas on the other side, we have centralized wastewater treatment, which cater thousands of population and even can go up to millions. So we have many of these decentralized wastewater treatment plants in Malaysia, especially located in old township, suburban, and rural areas. So we hope to see, or we hope to discuss today, evolve on the operation, performance, technological advancement, and health implication of the decentralized STPs. So without further ado, I would like to invite our across the globe speaker, Professor Graham, to give his presentation. And meanwhile, as this program is being broadcast through Facebook and also YouTube, the audience are invited to provide their question and comment in the chat book, and we will address this later. So the floor is yours, Professor.
Thank you, Azmi. I'm going to share my screen because I've got a few slides that I'm going to talk to. Just make sure we've got it. So can you see my screen? Can you see my screen? Can you see the screen?
David, you can speak now. We can see your screen now.
Okay, that's great. I decided I'm only going to speak for a few minutes, but I thought I'd basically bring up two things that are follow-ons from yesterday. First, I'm going to talk a little bit about a bit of a recap from some things that were said yesterday that I thought were particularly relevant. And then I was going to bring up one thing we didn't talk about yesterday. And me as a viewer of the presentations yesterday, the talk that had the most influence on me was the talk by IWK. And I thought it was extremely interesting on the array and diversity of smaller wastewater treatment plants across Malaysia. And it struck me though, in looking at the treatment plants and decentral, smaller versus larger plants, there was two reasons why you had a smaller plant. One was that it was a traditional thing related to a relatively older technology, maybe in an older community, I don't really know. But there was planning and thought towards trying to achieve Sustainable Development Goal 6.3. And the question is, when you have a network like that in Malaysia, and to be honest, Malaysia is not really different than the UK or any other place in the world, is that when you've got a lot of older, smaller plants, the question is, what do you do? Do you just try and consolidate those small plants, sometimes that are not working maybe as well as they could, into a whole series of centralized larger plants, or do you try and upgrade the smaller ones? And that's sort of the big decision from a management perspective, is what do you do? And I'll talk about that briefly in a moment. The other thought that struck me about the IWK network was that it's an amazingly diverse array of technologies and places. And our Newton project that's supporting this workshop was very small case study, but it struck me that one could do something at a slightly larger scale across the network and learn a huge amount based on what's in Malaysia to basically inform other places in the world. The other question is more a question to other people in the group. We've now seen a nice picture of what's in Malaysia. I'd be curious about how this compares to what you find in other countries in Southeast Asia. We work in a number of other countries, but I was very impressed by the breadth of the treatment that existed in the country. So going back to something I said yesterday in the presentation, I've changed this. It's the same slide, but I've changed the title. And I had this slide as a case for decentralization, but now that I've looked at what exists in Malaysia more carefully, it's really a case for planned decentralization. Sometimes decentralization is just something that's happened, but one of the pitches that we're trying to promote really everywhere in the world is that decentralization should be a goal in some scenarios rather than the default. And this comes back to the fact that if you don't have sewers or infrastructure in particular places, building big treatment plants and building long sewers isn't a very economical thing to do. And the question is, where's the break point between which you centralize versus decentralize? Just as an example, this was a slide that was from a paper we wrote a couple of years ago. And what if you look at it, and I've only flagged a few places, but these are the countries that I've circled are places that I think are very suitable for decentralization. The question is whether you decentralize and improve, or you decentralize with new technologies. But the bottom line is that we still have the problem where some of these small technologies don't work very well. Now, they don't work very well sometimes because they're not managed extensively, but also they don't work very well because they're small. And small actually matters when it comes to biological treatment if secondary treatment is what you're really aspiring for. So just to provide background, about 5 or 6 years ago, I was involved in a study with Jim Hall at Oxford trying to assess the relative economics of centralization versus decentralization on a national level. And this is sort of the very tip of what might be a good thing in Malaysia. And I think from hearing the IWA talk yesterday, this probably has been done to some extent within the country. But the bottom line, there's a couple of take-home messages on this graph. What this graph basically shows is based on a mathematical analysis of 2,000 treatment plants across the UK. And what we wanted to do is look at the key factors that argued in favor of either centralization, in other words, upgrading and centralization versus upgrading and decentralization. And there's a couple of things that pop out of this graph that I think are really useful. This is in a paper that's in a book from 2016 that we wrote. It's basically couple of things are important. First is the type of technology you use matters. Some technologies are better when they're operated at a small scale, particularly biofilm-based technologies. They tend to deal well with the lesser attention that a small technology in a rural or suburban environment will exist. Second is the relative clustering of communities in the vicinity of each other really matters. That if you've got a lot of small communities close, then centralization actually becomes a more and more economic thing to consider. Now, economics are not the only thing, but you also want to actually see, okay, what is the consequential effect this is going to have in health? And that is, as I said yesterday, is one of the hardest questions. The other thing is a more general topic, and it's not really related to this graph, and is whenever you're thinking about upgrading wastewater treatment, you basically have to plan for the unexpected. And we basically monitor and study treatment plants in a particular way right now. And this is a part of the decision relative to what technology you might consider in decentralization or what technology you might consider in centralization. But 6 months ago, we wouldn't have been thinking about the issue of things like virus, though we have always done that in wastewater treatment. But and in fact, the virus isn't really spread through wastewater, but the bottom line is it's an example of an unexpected thing that we should be thinking about when we're making these more strategic decisions relative to water and waste management. And it's something we should be doing in everything that we do relative to studying this question. Now, the final point I wanted to make, and then I'll pass it over to Professor Ujang, is the other thing that we've noticed is wastewater is not the same everywhere in the world. And in fact, this particular slide is related to work we've done to do with a global assessment of drug resistance in sewage. This is not treatment plants. This is just what's in sewage. And what you can see, just without explaining any of the details, is different parts of the world are quite different. Africa and South America have got the highest levels of resistance. Southeast Asia and Malaysia are probably in the middle tier. But the microbiomes and resistomes and the types of pollutants, including infectious disease, vary from place to place to place. And just to place this very, very confusing looking graph on the bottom left are called resistomes. It's the array of resistance genes, but we've also got equivalent information to do with microbiomes, which is the bacteria that's in the sewage. And that black hoop I've provided there, that's Malaysia, based on KL data. So what you can see is every place is very different. And so, and it is different in a biological sense, but it's also different in a chemical sense. So also when we're thinking about these decisions, this is another argument in favor of regionalization relative decision making. Malaysia will be the best place to make these decisions, but in Malaysia, people have to consider some of the things they don't expect. And that's among the things we have to think about relative to health. And so I'll re-pitch the document I was pitching yesterday, and that was this guidance that was developed. And basically the whole purpose of this guidance coming from the WHO is to develop national plans. Now, I think Malaysia is better than average when it comes to this, but this is something that any country anywhere should be thinking about. So with that said, I'll pass this over to Professor Ujang and have him provide his introductory comments.
Okay, thank you, Dr. Graham. So I think I will give the mic to Dato' Sri.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin wassalatu wassalamu ala sayyidina mursalin. First of all, I would like to report my sincere gratitude to all of you for inviting me to be here. And I would like to present my slides. Where are some slides? Oh, you want me to say? Okay, that's good. Hi, David, how are you?
Although I wish I was there.
Dr. Gusen is relaxing.
Not quite. I'm still here. I'm listening.
First of all, I would like to thank the organizing committee for this opportunity. Okay, let me give my insights on few things in relation to environmental sustainability. Basically, this is what we are trying to do, to have inerts and microorganisms to be filtered out from wastewater. And if possible, we can have a layer of membrane and something like that. But in short, for the past many years, the purpose of wastewater engineering, if you learned from the very basic, it started with, according to the books, it started with preliminary treatment, primary, secondary, nutrient removal, disinfection, and we have all this, yeah. So, but I think it's very important for us. If I were to write a book on wastewater in the future, I would go by objectives. It's not by set of systems, units, and units or bioprocesses that we have. So, for example, by number one is waste collection. We have to remove waste. Otherwise, you will be in danger of solid waste management, where you don't know the most efficient way to collect. And the second is public health. The third one is resource enrichment, means that you have additional water in the Malaysian plan that we are drafting at the moment. By 2030, we are aiming to have 1,500 MLD of reclaimed water. This is to, we make it known next few days. Make sure that whatever resources we have, you don't want to let it go. It can be used for many purposes, especially industrial. Then nutrient removal and water recycling. So this is the outcomes. I think it is more appropriate now to talk about the outcomes rather than what is the size of the wastewater treatment plant we are talking about. What are the most efficient technology? If it is cheap and it can meet all the requirements, so we go for it. Yeah, instead of obliging, because my PhD is on activated carbon, I want to use activated carbon everywhere. So this is the perceptions of many of us now, being in academics for so long. So I found that is the sickness within the academic community. They want to sell whatever they know without able to learn something new. I'm so sorry, David, I'm saying that. You can disagree with me, but I think this is important. Resource versus waste is something that we have to identify. What is useful, what is wasteful, what is healthy and what is harmful, and what is also important, what is good, what is bad. So by having that, we be able to use various kind of technology, and by matching them with the outcomes, we'll get what I call matching CBA, cost-benefit analysis. I give you an example. For the past many years, advanced wastewater treatment plants are being funded by oil and gas company, especially if you're thinking of advanced solid liquid separation, advanced liquid separation, membrane treatment. It's all funded in the first place in the earlier stage by military and oil and gas. Yeah. Then food and beverage, manufacturing, agriculture, and environment. And this is the opportunity for us to look back into this. I think now we have from linear economy into circular economy. In the past, we extract as much water possible, we supply, we use it, and then we treat it and we dispose it. That's the linear economy. But in the future, we are not going to do that. We think that whatever we extracted from the natural environment can be used up to a certain level. I think today we are here to discuss clean water and sanitation from the perspective of SDG. Yeah, so this is what we discuss in World Health Organizations. For example, we have this for many years discussing, and then recently we came back with a nice sanitation and safety planning. Started with safe use and disposal of wastewater, grey water, and excreta in it. In particular. So we have to prepare the SSP, and then we describe the sanitation systems, whether it is small, decentralized, or centralized facilities. Yeah, in Malaysia we have about 7,000 registered facilities by IWK. So we have other pockets in Peninsular Malaysia, in Pasir Gudang, Johor Bahru. I don't know why, Ridwan, two districts in Johor, very distinct, not connected to the system. Then we have Kelantan. Kelantan is, I think, in a few months, we are going to migrate to IWK in terms of system. And then Basra is different. Yeah? So identify hazardous events, assess existing control measures and exposure risk, and then develop and implement an incremental improvement plan. This is very important, it's very expensive. In Malaysia, we have 3 ways to fund our sewerage programs. First, by developers, by housing developers. So if you are staying in Johor, say for example, in particular, almost all residentials in Johor at the moment, in Johor Bahru, are, I think, funded through the mechanism that initiated by project proponents, is the developers. And I think this is very important and very unique. Not many countries in the world can do that. Not many countries in the world can do that. Our neighboring countries, except Singapore, are still struggling to have that framework in mind. If you buy houses, you are buying housing without wastewater facilities. Yeah, in many places. I don't want to name countries, but you can check. Yeah, and then this is very special to Malaysia. Therefore, we are quite advanced in at least medium-sized decentralized facilities. Okay. If you look into wastewater health and human being, investment in water supply and sanitation, I think it can be developed through this framework. I think the first one is where to be invested in the future. Places like Malaysia has less importance in terms of urgency compared to, say, for example, in India or in many Arab countries, or in Africa in particular. We can see that places like Malaysia, Indonesia, China, we have low in terms of adult mortality rate for WHO sanitary regions. Yeah. I think this is the most important chart. Linkaging indicators of sanitation, wastewater, and water quality. You can see that on my right is domestic sector, is household and public services, and the population with sanitation services. You can see basic services at home, hand hygiene, treatment technology for on-site and off-site services, and we have also basic services in school and healthcare facilities. This is the treatment of wastewater. One is treatment performance for grey water and black water flows from on-site and off-site services. And we have also safe reuse of treated wastewater in the system. You can see that at the end, we are talking about quality of inland waters. This is where you get your water resources from. Places like Putrajaya receiving water from Semenyih water treatment plant. So this is very important. You have to listen, those who are staying in Putrajaya. We are receiving water from Semenyih sewage water treatment plant, which is about from here, probably about 2 kilometers away. Yeah, from here. And upstream of this wastewater treatment plant, upstream of this water treatment plant, we have more than 200 small decentralized sewage treatment plants. So by definition, the base flow is not more than 10%. And this is what we are relying on for our water resources. So we have Semenyih Dam, but Semenyih Dam is just to maintain the base flow. And the rest is all discharges from largely sewage treatment plant. Small, decentralized sewage treatment plant, sizes ranging from, say, for example, 20 to 50,000 PE, population equivalent. Yeah? So it's very important. And the Semenyih water treatment plant provide water supply to 600,000 people, 6,000 people, 600 MLD. 600 MLD berapa, Radwan? Bagi pada berapa orang? It's time 4 or time 5, I made time 4, yeah? It's about 2 million population relying on this sewage water treatment plant, yeah? And then the upstream of that water treatment plant, we can find easily more than 200 small decentralized sewage treatment plant. But this is built by project proponents, developer of residential in particular. So the question is, if we are not able to keep the discharges from these sewage treatment plants at a certain level, we are in danger of putting our water resources at risk. You just imagine 90% of the water flows to that river, to that water intakes from discharges from sewage treatment plant. Therefore, if you learn or study about water supply, don't forget to study also wastewater engineering, because it's very important. Okay, this is what we are interested on at the ministry, to correlate between SDG targets and the water sanitation that we are using within the framework of wastewater and recycling framework. And this is the highlights of the study, which is very important. Model wastewater treatment technologies and sectoral and household waste outputs. So what is important here? Factor use cost partly linked to water and sanitation coverage in sub-Saharan Africa and South Asia. Yeah, and higher regional differences in factor scarcity rents, increasing in EU, Japan, and Korea. So this is important for us as policymaker. When we talk about the whole water ecosystem, factor use cost is very prominent in Africa and South Asia. But if you are thinking of other regions, factor scarcity rents means that because of the scarcity of water, they are willing to pay more, they are willing to invest more using better technology, better facilities. Yeah, so to make sure that they get better water supply in particular. So you can see other studies done, and this is very important: sanitation safety plan and water safety planning. I was involved in water safety planning for 15 years ago or 20 years ago, and I see that there are a lot of similarity. One of them, obvious similarity, is on the regulatory framework. In sanitation safety planning, regulatory framework is not that prominent, especially when we talk about individual septic tank, small scale offsite sewage treatment plant. It's difficult for you to monitor as a government, as a regulator. Unlike water safety planning, where you can easily have that in place, because people are afraid if you are not drinking good quality water, you might get various kind of diseases. So, okay, I want to end my presentation by putting this in place. I'm talking to scientists largely. This is the first thing you do. If you have something interesting to research on, you do scientific research. And after that, you have to prove some concepts. And then you start to think how to commercialize that. And the best thing that I think we can embark on is to go on open market. If you rely so much on subsidy, you will not survive. You must be able to survive in open market and link that with government policy, SDG targets and whatnot. And finally, by cultural adaptation. I give you an example. This is a classical example. Many of my books recently are using this example. It's sewerage objectives and approaches. And the objective is to have high quality receiving waters. And this is linear framework where you extract water and then you use it, you collect them, and then you treat, and then you dispose. Yeah. This is what IWK and many companies similar to IWK doing. They collect wastewater from domestic and commercial premises, and then they connect. The question is, some of them are not connected. So, for example, if you are thinking of Kuala Lumpur at large, at the moment we have more than 6,000 population equivalent facilities for sewage treatment, collection and treatment. But the question is not all connected. Old houses are still not connected. Only new houses, new buildings, I think post 1980s are connected. The rest are not connected. Bungalows in close to UTM-KL, they are not connected. Yeah, and many buildings that I know very well. So probably about 20% not connected, 30% not connected in Kuala Lumpur at the moment. Yeah, in the biggest sewerage projects that we have at the moment in Langat sewerage facilities, the funding is about 1.6 billion. We are about to complete the projects. 30% of the people around that area, around the catchment, are not connected. Why? Because they have already opted old systems, some of them using septic tank and whatnot. So they they refuse to connect because it costs them about 10,000 to connect. And in addition, they have to pay IWK on monthly basis. So for them to say, what should I connect? Yeah. This includes places like Pulau Pinang and Port Dickson. So in order to sustain, because of low connectivity, and then we have access, we are now allowing industrial premises to be connected to sewer. So this is new thing in Malaysia. I think we started this year. Last year we tried to start, or the year before we tried to start, but it was not able to do it. So we are trying to do it now by having industrial premises. And instead of having STP at the end, now we are trying to use water reclamation plant in between. So because industrial premises are already in the loop, so we treat, and about 70% of the water to be recycled. And then this is, if you are not able to be connected, we can have constructed wetlands at the end. Yeah, this is easier, no complaint from people because they don't have money to pay for the connectivity and whatnot. And this is what we hope in the future that we can do. So I just give you an example. We migrate from the first one, and then we have 4 more options in the future. And this is largely because of health, sanitation, and financial consideration. Thank you for that. Assalamualaikum.
Okay, thank you, Dato', for your presentation, and also for Professor Graham's presentation just now. I think it covers quite broad topics. Professor Graham basically covers more on the decentralized wastewater treatment, comparing Malaysia and different other countries, especially in Southeast Asia. And Dato' Sri was covering many from treatment processes, from what we have in Malaysia in terms of centralization, and what are the future for Malaysia sewage industry. So I think it's time for us to open the forum to question from either from the floor now, or also from our audience connected online. Anybody? Yes.
Thank you, and congratulations, Dato' Sri, for very interesting presentation. You highlight very important issues relating to sewage water pipeline. There are at least 200 small SPP in the upstream. And this is actually common in other part of the world as well. We are actually drinking water from water that has been flushed many times. Then the issue is whether the treatment system is efficient or not. If the treatment system is efficient, then I think we have safe water to drink. At the same time, when we talk about treating reclaimed water connected to the water supply system and then used for domestic purposes, it seems that it is too.
Oh, no, that is industrial.
No. Normally we connect it to industry. I think since our condition, it seems that the reclaimed water is possibly cleaner than the sewage water. That's the point. So therefore, it is, I think it's acceptable if we can treat that reclaimed water, then connect it to the water system, used for domestic water, just like new water. But problem is apparently people are reluctant to use that on the basis that the source is actually from sewage. But at the same time, they don't realize that actually the water quality in the river is possibly worse compared to the reclaimed water. What's your comment?
Nak cakap sekali. Biasa hari dia tak cakap tak boleh. Bagi pun tak bagi.
And sewerage charges. In Singapore, for every dollar that you spend on water supply, you are paying 115% on sewerage. So if you are paying $100 for your water supply, you are paying additional $115 for your sewerage. So your water bill is $250 with one toilet. If you have two toilets, additional another 15%. So if you have two toilets at home, you are paying 230 $30. So it shows that sewerage is more difficult to be treated and more troublesome. But in Malaysia, whatever you, the size of your house, you are paying only 8 ringgit for the connections. If you have 8 toilets in your house, you pay 8 ringgit. One toilet, 8 ringgit. Yeah, so I think this is to be corrected. And people ask me, why should I pay more? I say that most of us are drinking our water from discharges from sewage treatment plant. So make sure that our sewage treatment plant have sufficient funding for better treatment facilities. So the question is financial. What government of Malaysia is doing for the past many years is to, I mentioned three sources of funding for sewerage facilities. The first one is from developers, project initiators. They have to pay everything. Second is grant from government. Grants you don't have to pay back. It is a subsidy. And every year we are spending about 1.6, 1.7 billion every year. So this is what we discussed. If you follow discussion in Parliament last night, 7:45 to 8:50, we were discussing about this budget. And this budget for this year is about 1.6 billion. And then the third one, which is very important, it is the money that we collected from developers when they build facilities for that facilities to be upgraded in the future. So this money is under a trust fund, and this trust fund is to be utilized from time to time. So this year we are spending about 600 million on that. So all in, we have in our pocket roughly about 5 billion a year to spend on sewerage services, and this is very, I think, lucrative compared to other countries in the world. Yeah. So why I'm saying this is the source of money income for us, expenditure on sewerage services. Okay, that is on the capex, the capital expenditure. This is excluding operating expenditure, OPEX. OPEX require charges that we collect from sewage charges, which is 8 ringgit a year. Yeah. So IWK income a year is about 800 billion. This is not sufficient. They require at least, I think, in order to have big facilities and improve facilities, they can do themselves. They need at least about 5 billion a year, so that we don't have to subsidize them. At the moment, we are subsidizing them using our own money indirectly. Yeah. So this is the situation. Professor Zul, you are right. But the question is, how can we increase the capability of the sewage treatment plant? We need money.
Okay, thank you. Before I go, we have questions from our online audience. But before that, I think Professor Graham have something to say. Professor Graham?
Yes, thank you. I actually wanted to say a few things after Professor Ujang's comments, because he and I think almost identically when it comes to some of the problems we're talking about here. But I wanted to highlight two quick things. First is he made it. There was a comment originally about academics and them promoting their favorite solutions, and I actually completely agree with that. I think there's a real problem of academics trying to force feed their favorite solution onto every problem. And in fact, that's sort of the opposite of the perspective that we have relative to what I do. But maybe that's because I worked as a professional engineer for 10 years designing systems that serve purposes of clients. But the other thing I wanted to say is that it's not just academics that tend to force feed technologies onto systems. Industries do the same. I'm not talking about IWK because I haven't seen that there, but I've seen it in other countries where a company will come in from the outside and tell the local area that they must use their technology, even if their technology has no value relative to the local place. So I think people in positions of influence like Professor Ujang are very wise in the sense of understanding the fact that there's bias in terms of the advice they get. But I also believe there's bias in industry as well. The other point I wanted to make, and I think it's quite important when it comes to making decisions about, especially decentralized treatment solutions, is the behavior of people and what they do really matters. Generally speaking, how people behave as a group becomes more and more important relative to the waste and sanitation management as the system gets smaller, because the behavior of individuals really can consequentially affect what happens on a local scale. So one of the things that we've particularly been doing in India is trying to work with on the behavioral side and looking at how we could make better advantage of waste treatment facilities by helping and teaching and training and having people understand the consequences of their actions relative to the cost it has to the community, such as overusing water in one place or discharging their waste in another place, which affect other people. Anyway, I thought that it was something that was important to recognize, and I think the route back is that I'm very impressed by the plans in Malaysia, and I would be curious as to whether Professor Ujang had any comments about the social behavioral side relative to the work he's doing. Thank you.
Okay, thank you, Professor Graham. Dato', you have any comment? No? Okay, all right. So we have centralized treatment system and we have decentralized. And also decentralized treatment system also have different categories. There are some quite big, maybe 30,000-40,000 population equivalent, but we also have smaller one. In Johor Bahru, for example, we have many which only have around less than 1,000 population equivalent. And also, of course, there are limitations why we have to have our decentralized in certain areas and why certain areas are possible to have centralized treatment system. So maybe there's a question here. Is it possible to have a centralized treatment system in rural area? And if not, what are the limitations of this decentralized treatment plant? And of course, in certain areas, for example, in Japan, for example, they have Tokasho, yeah, in rural areas and also in places which is difficult to be connected, and they have their own policies on that. So how is it? How is our in Malaysia for us in dealing with that?
I think this water management in countries like Malaysia can be divided into 5 categories. Yeah. One is newly developed township, such as Ujang, Sapajaya, Nusajaya, Skudai, and the rest. This is newly developed township. I mean, you can request for. I mean, if you want to develop the housing facilities, the residential, it's very easy for us to just follow our flowchart 1, 2, 3, 4, 5. I think easy. You can put almost everything. This morning we had discussion with Petronas on NOx and SOx because we have tighter regulation on that. They said that we don't have any problems with the new facilities, but our problem is the facilities that we built 36 years ago, 25 years ago. If you do something on the structure might collapse. You just want to change something, little thing in the whole system, and it will be very difficult. So that's number one. Number two is all townships with mixed residential, mixed facilities, new buildings and whatnot. So you can use that new buildings, new facilities to lay down the sewerage connections easily, because you ask them to connect from A to B. 2 weeks ago, I met a contractor, and the company developed something in Kampung Baru, Kuala Lumpur, and they were asked to connect to a point, a manhole of, operated by IWK at the moment, which is about 200 meters away, instead of connecting in front of them, because we want to lay down new pipelines. Yeah, and they said, why should I go for 200 meters when I just punch to the closest sewer line in front of my building? I said, you cannot do that. The moment you do that, it will be overloading, and then the water will, the flush sewage will be backwash to your facility. So you don't put that. So you have to lay down, and because of that, they are able to do it. Yeah, and then in between, we can have another 200 people connecting to that, to the new facilities. So it is very important for us to have big corporations such as IWK to have that plan ahead, and then we can plan easily. Old buildings, from time to time, they need to be refurbished, and we make new requirement for them to have a kind of sewage treatment facilities. Okay, that's number two. Number three, where places that you cannot do anything. So in these places, you have to do, at the end, some simple facilities such as constructed wetlands. You forget about connecting people, connect all these, sometimes it's very difficult. Yeah? So this is what we are trying to do in many places that we have already started. I think by next year, there are more townships that we are talking about, the whole townships. I don't want to name the towns because you might consider old town where there is no connections, there is no sewage treatment plant at the moment, but that is critical. The criticality of that project is based on the existing of water intake downstream. Say, for example, downstream of Bentong, Raup. So at the end is cloud dam, yeah, and then cloud connections. Then that water is to be supplied to Langat 2, 1,130 MLD. So we know that that's very critical. The upstream township, which is not sewered at the moment, need to be sewered. And we can't afford to have the whole community to be connected. But what best we can do, the easiest we can do, construct the wetlands. What is the best example of construct wetlands? Is Putrajaya. Yeah, so if you come to Putrajaya, you must appreciate that wetlands that we have is one of the best in the world. You can see the water is very clean. And the fifth category is sensitive area. Sensitive areas such as Tioman, Pulau Redang, Pulau Perhentian, you can't sewer that facilities because it is very, very, very sparse and not many people living. During non-season for tourism, it's only 200 people living in that vicinity. During peak tourism seasons, you can get about additional about 1,000 at any point of time. So with that situation, we need different approach. I think Jokasho kind of thing will be good in that situation. Yeah, and then the question is, yeah, we made calculation. If we sewer the whole Pulau Perhentian, per head is subsidized by at least 200,000 per head. Yeah, because we want to have about 2,000 PE. Per head is about 200,000 PE. If we supply each premise by one Jokasho, that costs us about 10,000. So we can subsidize per family only 10,000. So it is much cheaper to give Jokasho to everyone every 10 years compared to sewer the whole thing. That costs us 200,000 per PE. Yeah. Jokasho OPEX is after the people. Yeah. So now they develop very cheap energy efficient geocaching system that I have seen. So the rest we can use whatever options on site, septic tank. Septic tank still, I think, important for countries like Malaysia. If you go to United States, most of the remote areas are all supplied by septic tank.
Maybe one more question, or if Professor Graham has anything to comment.
I was just going to comment on a couple of the online. There's a couple of online questions that I could quickly respond to. One was, is the characteristics of the effluent varies? How does that impact the economics of small versus large systems? And it can, depending upon what your regulatory rules are saying, what you should be removing from the waste. But that's the reason. That's a good question, because it's one of the pitches we've been making is that you have to understand your own waste, and every place in the world is a bit different. And so then you have to determine how you prioritize your treatment technologies, because you cannot cookie cutter solutions. So by understanding what's local, then you can determine the economics of your own scenario. So that's the answer to that question. So the answer is local factors can matter, but the best way to learn that is just doing an analysis of your own system and to understand your own system in a little more detail. And it's not just doing COD and BOD, it's doing other characteristics of the waste to truly understand the waste. The other comment was, does the performance of centralized versus decentralized waste treatment plants differ? And the answer is, typically they do. The performance of small treatment plants, generally speaking, on average, are okay. The problem with small treatment plants is their performance varies much more widely over time. And small treatment plants are more likely to fail. And it's just because there isn't enough buffering in the community, especially in a climate where flow rates in terms of rainfall vary so much. So my comment is that, one of the disadvantages of small plants is that they are less reliable, even though their mean performance may not be that bad. And therefore, when you're looking at decentralized technologies, they need to have some sort of, they have to be designed in a resilient sort of way. Like, I don't like activated sludge plants for decentralization. I much prefer biofilm. And I also agree with Professor Ujang about wetlands. Wetlands are tremendous. And you should be using them whenever possible and their space is available. So that's those are my final comments.
David, I think I would like to indicate the budget of the Ministry of Environment and Water in Malaysia to illustrate the importance and our concentration. For this year, we have 1.6 billion for sewerage projects, 1 billion for water supply, and 1 billion for drainage and irrigation and coastal protection. So you can see that the biggest budget is on sewerage. Yeah. So it is what is illustrated in the water bill in Singapore. Sewerage is more expensive than water supply, and then it is more difficult to get funded. The second point that I'm going to conclude, I think we have to be mindful of the practicality of decentralized and centralization. The biggest difficulties on centralization on top of financing is the complexity of the work. Say, for example, yesterday I visited Bunus water treatment plant. Bunus is located in front of UTM KL campus. Yeah, it is for 1 million population equivalent, but the biggest connection to Bunus is what we call D44, and D44 is about 400 million ringgit Malaysia worth of investment, and it is to lay down pipes for 55 kilometers And we found that 10 kilometers within that stretch of sewer network is full of very hard stone, very hard materials to grill, and you require very special machines. And every day you can go only 300 mm. 300 mm, this much. Yeah, we have 6 machines at the moment, and the machines will be broken every 3 weeks or something like that. That you have to wait for another machine to come. So the complexity is tremendous. Those who are interested to visit, come with me. I can show you. It is in front of UTM. You can see that the hole in front of UTM, the shaft in front of UTM, so we have already built the hole for the past 3 years. It's 15-meter deep. This is by gravity. So you just imagine how difficult it is. And we are now talking about what kind of machine we have. All machines in the country are now located in this area. Yeah, and then we are still buying new machines to make sure that we can to make proper drilling for that. Yeah. And it's only about 2.1 meter in diameter. This is not suitable, the one that we use for MRT. MRT is about 8 meters. Yeah, thank you.
I think there's this question from Mr. Asari. How does the performance of the centralized plants compare to the decentralized? It has been answered by David just now. Okay, I think most of the questions has been answered, and with the limited time, I think we have to stop now. Because we are online, it is not as flexible as it is physical when you have to log your meeting. So we have to stop and we have to stop. I would like to thank Dr. Sri Ujang for his time with us, and also Professor Graham. I think we have, although it is short, but I think lots of information are being transferred to us, and we know now that sewerage system or maintenance sewage system and business sewage system is not cheap. It is expensive, and I hope one day people will realize the importance of it. But I hope the realization will come very soon, not too late. Okay, so thank you very much, Dato. Thank you, Professor Graham. And with that, I would like to give back this session to our MC.
Okay, a big thank you to our moderator and panelists for sharing their knowledge and experiences with us today. As a token of our appreciation to our panelists, I graciously invite Prof. Azmi Aris to present this memento to our panel. Yang berbahagia Datuk Seri Insinyur Dr. Zaini Ujang. Okay, Prof. David Graham, thank you for joining us today. We will end this session and move to the session. Thank you also to FB and YouTube viewers. On behalf of the organizer, we apologize for any